So this is number 27 of your Moodle Quiz 3. A solution of 20 milliliters of 0.71 molar sulfuric acid is mixed with 40 milliliters of 0.71 molar sodium hydroxide, which is an acid-base neutralization reaction. And you'll notice here, when you combine these two, you end up getting a salt and water. So you get an aqueous solution afterwards. The temperature of the system changes from 23 degrees to 32.48. What is the molar enthalpy, or the delta H, of this reaction? So first of all, we have CS times G times delta T, because we have a change in temperature that occurs as a result of a reaction, which we'll use moles times delta H. So here our CS is going to be 4.184 joules per gram Celsius times, and the grams of our entire system is going to be the 20 milliliters plus the 40 milliliters at a density of 1 gram per milliliter. So we can say 20.0 grams plus 40.0 grams times the change in temperature is going to be 32.48 minus 23.0. This is all going to be equal to the negative moles. Now here's where you have to make a choice. We're either going to use the moles of sulfuric acid or the moles of sodium hydroxide, because we're really only interested in their ratio to the amount of product that'll be produced, the sodium sulfate. And I would recommend sticking with the option that has a coefficient of 1 or a 1-to-1 ratio with your product. So we're going to go with sulfuric acid here, and we'll say there's a negative and 0.71 molar times 0.020 liters of H2SO4, and this gives us moles. And what I'm trying to find is what is the delta H. Okay, so now this is the setup of our equation, and we can go ahead and solve it. When I multiply everything on the left side of the equation, I get 2,379. And that'll be equal to, when I simplify this, I get a negative 0.0142, and then delta H is what I'm solving for. Keep in mind that this is in a unit of joules at this moment. The grams cancel, the Celsius cancel. And then over here, this is just my moles. So now I'll divide both sides by negative 0.0142, and that's going to give me an answer of negative 167,535. That's joules per mole. But normally delta H is reported in kilojoules. So I'm actually going to go ahead and convert this. 1,000 joules is equal to 1 kilojoule. So I want to divide by 1,000. And so that'll give me negative 167.6 kilojoules per mole for your delta H. The per mole is important because had we used the sodium hydroxide, we would actually have to divide by 2, since there's 2 moles worth of sodium hydroxide. So that's another reason why it's really better to just stick with whatever has a coefficient of a 1 or a ratio of 1.